The universe stretches far beyond what the human mind can truly comprehend. Its immense scale has always fascinated humanity, sparking an endless quest to explore the unknown. To understand what lies beyond, we must first uncover the mysteries within our own cosmic neighborhood. Today, we embark on an extraordinary journey through the vastness of space, uncovering the wonders hidden within the cosmos. Our adventure begins right here in our solar system, where planets, moons, and celestial bodies orbit a brilliant star, the Sun. As we travel outward, we will witness breathtaking images captured by space probes, revealing the astonishing beauty of our neighboring worlds. Moving beyond the comfort of our own planetary system, we set our sights on Alpha Centauri, the closest star system to Earth. What secrets does it hold? Could there be planets harboring life, or are we truly alone in the universe? As we drift further, we encounter the most mysterious and powerful entities in the cosmos, black holes. These enigmatic voids not only consume everything in their path, but may also shape galaxies and give birth to new stars, playing a crucial role in the cosmic cycle of creation and destruction. But our journey does not stop here. We push past the observable universe, venturing into realms that challenge the very fabric of reality. Could there be another version of you in a parallel cosmos? Is our universe just one of many in an infinite multiverse? The answers to these questions remain hidden among the stars. Yet, with every discovery, we inch closer to unlocking the deepest secrets of existence. So, fasten your seatbelt as we embark on this thrilling voyage through time and space, where science meets the unimaginable and the universe reveals its endless wonders. The cosmos is a vast and mysterious expanse, stretching far beyond what we can perceive. For centuries, humanity has gazed at the stars, wondering what secrets they hold and what lies beyond the edge of the known universe. To uncover these mysteries, we must first explore the celestial wonders within our reach. Our journey begins in our own solar system, home to 8 planets, countless moons, and a host of other celestial bodies orbiting the radiant sun. This massive star, burning at an astonishing 5,700 degrees Celsius, 10,300 degrees Fahrenheit on its surface, is the source of life and energy for our world. Yet, its outermost layer, the corona, burns even hotter than its surface, an unsolved puzzle in astrophysics. As we venture further, we encounter Alpha Centauri, the closest star system to Earth. Could it host planets similar to ours? The possibility of extraterrestrial life lingers in our thoughts, fueling the curiosity that drives space exploration. Deeper into the cosmos, we face the enigmatic and terrifying black holes, regions of space where gravity is so intense that nothing, not even light, can escape. These celestial giants are not just cosmic destroyers. They play a crucial role in shaping galaxies and birthing new stars, proving that even destruction can lead to creation. Beyond black holes lies the edge of the observable universe, a boundary that may not be the ultimate limit. Could there be alternate realities, parallel universes, or unseen dimensions? Science has yet to provide definitive answers, but every new discovery brings us closer to understanding the true nature of existence. As we continue to explore, one thing remains certain: the universe is a place of infinite wonder, waiting to be uncovered. So, let's embark on this cosmic voyage together, where every star, every planet, and every mystery brings us one step closer to understanding the grand design. Sometimes, These prominences break off from the star's surface, potentially disabling Earth's satellites and even endangering the crew aboard the ISS. They also trigger powerful magnetic storms, disrupting radio signals and affecting people's sensitivity to weather changes. But that's not what scientists fear the most. Their biggest concern is that a prominence could grow large enough to threaten all life on our planet. The device also captured several images using the SPICE tool, which utilizes UV light to reveal different layers of the sun. From the outer corona to the chromosphere, each layer becomes visible as we approach the surface. In the SPICE image sequence, purple represents hydrogen gas at 5,500 degrees. Fahrenheit blue indicates carbon at 17,700 degrees. Fahrenheit green shows oxygen at 177,000 degrees. Fahrenheit yellow highlights neon at 350,000 degrees Fahrenheit. According to NASA scientists, this is just the beginning. This advanced equipment will continue flying close to the sun multiple times, observing it from various angles. It will also provide a rare glimpse of the sun's uncharted polar regions, an exciting breakthrough in solar research. Now, let's turn our attention to the planets. Mercury, the first planet in the solar system, is located approximately 36 million miles from the sun. It is the smallest planet. Swing only slightly larger than the moon. Due to its proximity to the sun, its surface reaches 800 degrees Fahrenheit during the day and drops to negative 310 degrees Fahrenheit at night. Reality. Scientists and professors, thanks to this incredible image, we now have a clearer view of the sun's upper atmosphere, known as the corona. On its surface, dark, thread-like structures can be seen. These are solar prominences. They appear as plasma filaments, twisting and extending outward in various shapes, ejecting massive amounts of coronal gas into space. These ejections play a crucial role in space weather, sometimes creating solar storms that impact our planet. However, their behavior is highly unpredictable. At times, these prominences break off from the sun's surface, and when they do, the effects can be devastating. Earth's satellites could be disabled, cutting off communications and navigation systems. Astronauts aboard the ISS could be exposed to lethal radiation. Additionally, these prominences trigger intense magnetic storms, which can interfere with radio signals, electrical grids, and even impact human health, affecting those who are sensitive to weather fluctuations. But despite these dangers, there is something even more concerning. Scientists fear the possibility that a solar prominence could grow to an enormous size, large enough to unleash destruction on a global scale, wiping out all life on Earth. While such an event is rare, the potential consequences make studying the sun more important than ever. To better understand our star, scientists use advanced instruments like the SPICE tool, which captures UV light images of the sun. These images allow us to observe each layer of the sun, from the outer corona to the chromosphere, as we get closer to the surface. The SPICE image sequence reveals different elements at various temperatures. Purple, hydrogen gas at 5,500 degrees Fahrenheit. Blue, carbon at 17,700 degrees Fahrenheit. Green, oxygen at 177,000 degrees Fahrenheit. Yellow, neon at 350,000 degrees Fahrenheit. According to NASA scientists, this is just the beginning. This advanced equipment will continue flying close to the sun, gathering new data from multiple angles. One of its most exciting tasks will be to observe the Sun's polar regions, which remain largely uncharted. Unlocking their mysteries will bring scientists one step closer to understanding solar activity, magnetic fields, and the potential risks Earth faces from extreme solar events. Moving on to the planets. Now, let's turn our attention to the planets of the solar system, starting with Mercury. Mercury, the first planet from the Sun, is located approximately 36 million miles away. It is also the smallest planet, only slightly larger than our Moon. Because of its proximity to the Sun, Mercury's surface experiences extreme temperature shifts. During the day, it can reach a scorching 800 degrees Fahrenheit, but at night, it plunges to a freezing negative 310 degrees Fahrenheit due to the lack of atmosphere to retain heat. The first image of Mercury was captured in 1962, marking a milestone in planetary exploration. Later, scientists created detailed surface maps using radar technology, allowing them to study the planet's craters, cliffs, and mysterious geological features. With each new mission, we uncover more about our solar system and the forces that shape it. From the Sun's powerful prominences to the harsh landscapes of Mercury, our quest for knowledge continues, bringing us closer to understanding the universe we live in. The most remarkable image of Venus was captured by the Soviet robotic module, Venera 14. This historic probe managed to land on Venus's rocky surface, enduring its harsh environment for an entire hour before finally succumbing to the planet's crushing atmospheric pressure, which is 90 times higher than Earth's, equivalent to the pressure you'd experience 3,000 feet below the ocean. In the image, we see a barren, rocky desert beneath a thick, yellowish sky filled with clouds of sulfuric acid. These clouds trap heat, making Venus the hottest planet in the solar system, with surface temperatures soaring above 900 degrees Fahrenheit, 475 degrees Celsius. Hot enough to melt lead, the thick, toxic atmosphere gives the planet an eerie glow and a distinctive rotting egg smell due to the high concentration of sulfur. Although this photo was taken over 40 years ago, scientists continue to digitally enhance and analyze Venus's surface using modern technology. Recent discoveries suggest that Venus might not be as geologically dead as once thought. Studies indicate active volcanoes reshaping the planet's surface and contributing to its hostile atmosphere. Moving from Venus to Earth, the planet of life. Leaving behind our mysterious twin planet, we now shift our focus to Earth, the only known planet to sustain life. Earth orbits the Sun at a distance of 93 million miles, 150 million kilometers, a position that allows it to maintain a delicate balance of temperature, atmosphere, and water, making it the perfect cradle for life. One of the most famous and awe-inspiring images of Earth ever captured is known as Earthrise. This breathtaking photograph was taken from the Moon by the crew of Apollo 8. The image shows Earth rising over the lunar horizon, a sight that had never been witnessed by humans before. Originally, the image was in black and white, but modern technology has allowed us to enhance and recolor it, bringing its true beauty to life. The Earthrise photo was more than just a scientific achievement. It changed the way humanity saw itself. For the first time, we could see our entire planet suspended in the vast darkness of space, a fragile blue sphere surrounded by nothingness. This image inspired the environmental movement, reminding us of the importance of protecting our one and only home. With every new mission, we uncover more about the planets that share our solar system. But no matter how many we explore, Earth remains the most extraordinary, a planet teeming with life, oceans, forests, and endless possibilities. Thanks to modern digital technology, it became possible to add color to the famous Earthrise photograph, giving us a more realistic and vibrant view of our home planet from space. However, this was not the first image of Earth taken from beyond its surface. 2 years earlier, in 1966, the robotic spacecraft Lunar Orbiter 1 captured the first ever black and white photograph of Earth from the Moon's orbit. This was a groundbreaking moment in space exploration, providing humanity with its first glimpse of our planet from such a vast distance. The International Space Station, a view of Earth from above. Fast forward to 2017, and technology has come a long way. That year, a stunning video was recorded aboard the International Space Station, capturing Earth from low orbit. The footage, taken at night, reveals the spectacular northern lights, a mesmerizing display of dancing green and red auroras caused by solar particles colliding with Earth's atmosphere. The video begins over North America, moving toward the Gulf of Mexico and along the Florida coastline. From there, we witness the stunning nighttime glow of European cities, followed by the Mediterranean Sea, where cloud formations are illuminated by flashes of lightning from distant thunderstorms. This breathtaking view reminds us of the sheer beauty of our planet, glowing like a jewel in the vastness of space. Earth's natural satellite, the Moon. As I mentioned earlier, Earth has a natural satellite, the Moon. While most planets have moons, Earth's moon is quite special. It is approximately 1/4 the diameter of Earth, making it one of the largest moons relative to its parent planet in the solar system. The moon's gravitational pull plays a crucial role in shaping life on Earth, primarily by controlling ocean tides. Its synchronous rotation means that the same side of the moon always faces Earth, which is why we never see the far side from our planet. In this historic Apollo 16 photograph, we see Commander John Young standing on the moon, waving at the camera. Beside him is the Lunar Roving Vehicle, LRV, commonly known as the Lunar Car. This vehicle allowed astronauts to explore vast distances on the moon, setting a speed record of 11 miles per hour, 18 kilometers per hour, the fastest any human has traveled on another celestial body. Mars, the red planet and humanity's next frontier, let's journey beyond Earth and its moon to Mars, named after the Roman god of war. Did you know that all planets in our solar system are named after ancient deities, except for Earth? Mars is located 140 million miles from the Sun, and for centuries, people speculated about the possibility of alien life on its surface. Even today, some still hope to find evidence of microbial life, though no concrete proof has been discovered so far. At present, NASA's Perseverance rover is actively exploring the Martian terrain, sending back high-resolution images. One such photo provides a close-up view of Mars's surface, revealing a landscape composed of red sand and rocky formations. The iron-rich soil gives the planet its distinctive reddish hue. Mars is considered the most suitable planet for future exploration and possible colonization. While its environment is harsh, it is still more hospitable than many other planets in our solar system. However, potential settlers would face significant challenges, including a lack of oxygen, freezing temperatures, and powerful dust storms that can last for months. One of the most astonishing features of Mars is Olympus Mons, the tallest volcano in the solar system. Standing at 16 miles, 26 kilometers high, it is nearly 3 times the height of Mount Everest. The sheer scale of this colossal shield volcano is a testament to the geological activity that once shaped Mars. The future of space exploration. With each passing year, technology brings us closer to unraveling the mysteries of our solar system. From the first fuzzy black and white images of Earth to high-definition videos of distant planets, our understanding of the universe continues to grow. Who knows? In the near future, we might not just be looking at images of Mars. We could be walking on its surface, taking our first steps toward becoming an interplanetary species. The gigantic Olympus Mons on Mars. Olympus Mons is a truly colossal volcano, standing at 16 miles, 26 kilometers high, which is 3 times taller than Mount Everest, the highest mountain on Earth. This breathtaking image was captured by the Chinese spacecraft Tianwen-1 in 2021 during its orbit around the Red Planet. Among the most groundbreaking discoveries were the first ever detailed photographs of Mars's South Pole, where almost all of the planet's water resources are thought to be concentrated. These images provide crucial insight into Mars's potential to support future human exploration and possibly even microbial life. Right now, scientists are exploring Mars more thoroughly than ever before. With rovers like Perseverance and orbiters like Tianwen-1 and Mars Reconnaissance Orbiter, we receive regular images of the Martian landscape, helping researchers study volcanic plains, ancient riverbeds, and mysterious geological formations. But let's venture further into our solar system, beyond the rocky planets, and explore the giants of gas and ice. Jupiter, the king of planets. Next in line is Jupiter, a gas giant located a staggering 485 million miles from the Sun. It is the largest planet in the solar system, so massive that all other planets could fit inside it with room to spare. The image you see now was taken by the Voyager 1 spacecraft in 1979. One of the most fascinating features of Jupiter is the Great Red Spot, a massive storm system that has been raging for at least 400 years. This storm is so large that it could fit 2 or 3 Earths inside it. But that's not all. In the lower left part of the image, you can see a bright spot. That's Europa, one of Jupiter's most famous moons. Scientists believe that beneath Europa's icy surface, there is a hidden ocean, possibly containing more liquid water than all of Earth's oceans combined. This raises exciting possibilities for extraterrestrial life. Another bright object in the top right is Io, another one of Jupiter's moons. Io is the most volcanically active body in the solar system, constantly reshaping itself. In fact, there are so many eruptions happening on Io that no impact craters can be found. Lava flows continuously cover any scars left by asteroids. Jupiter's mysterious ring system. Most people associate rings with Saturn, but Jupiter also has a faint ring system, which remained a mystery for decades. Until 2003, many believed Jupiter's rings were just a hypothesis. But NASA's Galileo spacecraft finally confirmed their existence. Scientists now believe these rings were formed by meteorites colliding with Jupiter's smaller moons, throwing dust and debris into orbit. Another breathtaking image was captured in the infrared range by the James Webb Space Telescope, revealing Jupiter's swirling clouds, storm systems, and magnetic fields in unprecedented detail. Jupiter's hidden rings and its 4 main moons. For decades, Jupiter's ring system remained a mystery, barely detectable with existing telescopes. But then came the James Webb Space Telescope, JWST, the most advanced space observatory ever built. It was JWST that finally provided us with the clearest and most detailed images of Jupiter's rings, revealing their structure, composition, and behavior in ways never seen before. But Jupiter's mysteries don't end with its rings. The gas giant is home to four major moons: Io, Europa, Ganymede, and Callisto. Each of these celestial bodies holds incredible secrets, making Jupiter a mini solar system of its own. Io, the most volcanically active moon. The first satellite, Io, is one of the most extreme and unusual moons in our solar system. Io is the most volcanically active celestial body we've ever observed. When Voyager 1 flew past in 1979, it discovered 9 active volcanoes erupting simultaneously. More eruptions were observed when Voyager 2 passed by later, confirming that Io is in a constant state of geological turmoil. The plumes of its volcanic eruptions rise over 185 miles, 300 kilometers above the surface, traveling at an astonishing 1.6 miles per second, 2.5 kilometers per second. This mesmerizing image shows an eruption composed mainly of sulfur and sulfur dioxide, creating a landscape that looks like something straight out of a science fiction film. Europa, the hidden ocean world. Next, we have Europa. And in my opinion, this is the most fascinating moon of them all. Beneath its thick ice crust, scientists believe there is a vast ocean, one that contains more liquid water than all of Earth's oceans combined. This raises a thrilling possibility: life. If microbial life ever developed on another world, Europa is one of the best places to find it. Future missions, such as NASA's Europa Clipper, will explore the moon further. Zrenia searching for signs of biological activity in its hidden ocean. Ganymede, the largest moon in the solar system. Moving on to Ganymede, the largest moon in our solar system, even bigger than Mercury and Pluto. But what makes it truly special is this: Ganymede is the only moon known to have its own magnetic field. On Earth, a magnetic field protects us from harmful solar radiation, and on Ganymede, it creates beautiful auroras, glowing ribbons of gas that encircle its poles. In 2021, NASA's Juno spacecraft took breathtaking new images of Ganymede, revealing craters, dark and light terrain, and evidence of past tectonic activity. Scientists believe that, just like Europa, Ganymede may also have a hidden ocean beneath its surface. Callisto, a cratered time capsule. The last of Jupiter's 4 major moons is Callisto, a world covered in ancient craters, making it one of the oldest landscapes in the solar system. This image, taken by NASA's Galileo spacecraft in the 1990s, shows a rugged surface dotted with bright white spots. Scientists believe these spots are ice deposits, hinting that Callisto, too, may hold frozen water beneath its crust. These images are truly breathtaking, and as new missions explore Jupiter's moons, we will continue to uncover more secrets hidden in their frozen landscapes. Saturn, the jewel of the solar system. Now, let's move even further from the Sun to Saturn, the second largest planet in the solar system, and arguably the most visually stunning. Saturn is unique because it is the only planet that could float on water if you could find a giant cosmic ocean large enough. This is because Saturn is made almost entirely of gases, like hydrogen and helium, giving it an incredibly low density. Located 915 million miles from the Sun, Saturn is best known for its majestic rings, which are made up of countless ice and rock particles, orbiting at incredible speeds. Cassini's legendary mission to Saturn. This iconic image of Saturn was captured by NASA's Cassini spacecraft in 2005. Cassini was one of the most ambitious planetary exploration missions ever attempted, spending 13 years orbiting Saturn from 2004 to 2017. During its mission, Cassini provided unprecedented detail of Saturn's rings, revealing their structure, composition, and dynamic changes over time. In this stunning image, we see Saturn's rings casting dramatic shadows onto the planet's surface, creating an ethereal golden glow. The mysterious blue hues of Saturn's northern hemisphere. Another fascinating detail captured by Cassini is Saturn's northern hemisphere, which appears partially blue. But why does Saturn, a planet known for its golden yellow tones, have this mysterious blue hue? It turns out the reason is similar to why Earth's sky is blue. In cloudless regions of Saturn's atmosphere, sunlight is scattered by gas molecules, making blue light more visible than red. However, what puzzles scientists is why some clouds remain golden, a mystery yet to be solved. With every image sent back from space, we are uncovering new mysteries and rewriting what we thought we knew about our cosmic neighborhood. And Saturn is just the beginning. Saturn's rings and its unique moons. Saturn's iconic rings are among the most breathtaking sights in the solar system. Two of its moons, Tethys and Mimas, can be seen on either side of these massive rings, providing a stunning view. At the top of Saturn, dark shadows are cast by the wide rings, revealing their exceptional complexity. When viewed in ultraviolet UV light, Saturn's cloud layers take on a textured appearance, showing intricate details that remain hidden in normal light. The end of the Cassini mission. Sadly, in 2017, NASA's Cassini spacecraft was commanded to dive into Saturn's atmosphere, marking the end of its legendary mission. Scientists made this decision to prevent Cassini from contaminating any of Saturn's potentially habitable moons, like Enceladus or Titan, Saturn's rings, a cosmic masterpiece. What truly sets Saturn apart from all other planets is its spectacular ring system, composed of 7 major rings. These rings are made up of billions of ice fragments, which perfectly reflect sunlight, making them clearly visible from Earth. The total radius of Saturn's rings extends a staggering 45,000 miles, 72,000 kilometers. However, their thickness is only 1.6 miles, 2.5 kilometers, an incredibly thin layer compared to their vast spread. It is believed that these rings are the remains of a destroyed moon, torn apart by Saturn's immense gravity billions of years ago. Uranus, the ice giant on its side. Moving even farther out, we reach Uranus, a blue-green planet located 1.8 billion miles from the Sun. To this day, the only spacecraft to ever visit Uranus was Voyager 2 in 1986. Why is Uranus blue? Unlike Saturn, Uranus has a cool blue color with hints of green due to the presence of methane gas in its atmosphere. This gas absorbs red light and reflects blue-green light, giving Uranus distinctive hue. Core composition. Uranus's core is primarily made of ice, and surface temperatures can drop to a chilling negative 371 degrees Fahrenheit, negative 224 degrees Celsius, making it one of the coldest planets in the solar system. Winds. The winds on Uranus are extremely powerful, reaching speeds of up to 560 miles per hour, 900 kilometers per hour. Rotation. Unlike any other planet, Uranus rotates on its side, making it a true oddity in the solar system. Scientists believe this unusual tilt was caused by a massive collision with an Earth-sized object billions of years ago. Voyager 2's stunning images. Voyager 2 captured two different images of Uranus, a natural color image showing the planet as it would appear to the human eye, an enhanced image where artificial colors and contrast were used to highlight cloud patterns and atmospheric features. Uranus's rings and moons. Although less bright than Saturn's rings, Uranus also has a ring system made up of dark, thin rings that are hard to see from Earth. Uranus is surrounded by 23 known moons, all of which are covered in thick layers of ice. Future NASA missions may focus on exploring Uranus more closely, with plans to send a dedicated spacecraft in the coming decades. Neptune, the most mysterious planet. The last planet in our solar system is Neptune, located 2.8 billion miles from the Sun. Because of its great distance, Neptune cannot be seen with the naked eye from Earth. Voyager 2's encounter with Neptune in 1989. Voyager 2 became the first and only spacecraft to visit Neptune. It captured a breathtaking image of Neptune and its largest moon, Triton, together in the crescent phase, creating an elegant and rare view. Due to the angle at which the image was taken, Neptune appears darker than usual, losing its vibrant blue color, the extreme weather of Neptune's size and mass. Neptune is smaller than Uranus in size, but it has a greater mass, making it the densest ice giant. Winds. Neptune holds the record for the strongest winds in the solar system, reaching 1,240 miles per hour, 2,000 kilometers per hour. Walking on this planet would be impossible. You'd be blown away instantly. The possibility of diamond rain. Due to Neptune's extreme temperatures and pressure, scientists believe that diamonds could form in the planet's atmosphere. These diamond rainstorms might fall deep into the interior, creating a planet-wide ocean of liquid carbon and diamond beneath its clouds. Our solar system, a never-ending journey of discovery. This is our home, the solar system. Every day, science advances and new space missions bring back incredible images that challenge what we know. With the arrival of the James Webb Space Telescope, JWST, we are seeing planets, moons, and cosmic structures in greater detail than ever before. The universe is vast, and with each discovery, we get closer to unraveling the mysteries that have surrounded us for centuries. Who knows what secrets the next generation of space explorers will uncover? Music. The James Webb Telescope. A new era of discovery. The James Webb Space Telescope, JWST, has provided us with some of the most detailed images of the universe ever captured. Among them, a breathtaking picture shows a few bright stars. But more importantly, it reveals countless distant galaxies, each holding the potential for new discoveries. With its cutting-edge technology, JWST has ushered in a new era of space exploration, allowing us to see further and deeper into the universe than ever before. Space is a miracle, one that humanity will continue to study for thousands of years to come. As the legendary Stephen Hawking once said, "I am not sure that the human race will live another 1,000 years if it does not find the opportunity to escape into space. The threats to life on Earth are many, but as an optimist, I believe that one day we will reach the stars." How far is our closest neighbor? To understand the challenges of interstellar travel, let's start with the fastest spacecraft ever built, Helios 2, designed to study the Sun. Speed, 157,000 miles per hour, 252,792 kilometers per hour. Percentage of light speed, 0.023%. That may seem fast, but on a cosmic scale, we are practically standing still. Now, let's imagine we use Helios 2 to travel to the Alpha Centauri system, our nearest star system. At this speed, the journey would take an astonishing 18,000 years. This is why we must push the boundaries of space technology if we ever hope to become an interstellar species. The mystery of Alpha Centauri, the Alpha Centauri system, has fascinated scientists, explorers, and science fiction writers for centuries. But what makes it so special? A system of 3 stars, Alpha Centauri A and Alpha Centauri B, are a pair of sun-like yellow dwarf stars that appear as one bright star to the naked eye. The third star, discovered in 1915 by British astronomer Robert Innes, is a red dwarf called Proxima Centauri. Proxima Centauri remains the closest known star to our Sun, located just 4.22 light-years away. This proximity, combined with its potential for habitable planets, has made Alpha Centauri a prime target for exploration. The search for habitable worlds. For decades, scientists have dreamed of finding Earth-like planets in Alpha Centauri. Initial observations suggested the presence of 2 planets, Centauri AB and Centauri BB. However, further studies ruled them out as habitable, leading to disappointment. Then, in 2016, everything changed. Scientists finally confirmed the existence of a real exoplanet orbiting Proxima Centauri. The discovery of Proxima Centauri B, this newly found world, named Proxima Centauri B, became one of the most promising exoplanets ever discovered. Key facts about Proxima Centauri B: distance from Earth, 4.22 light-years. Mass, 1.1 times that of Earth. Orbit, it circles Proxima Centauri within the habitable zone, where temperatures could allow liquid water to exist. How was it discovered? Finding Proxima Centauri B was extremely difficult because of its small size. Scientists confirmed its presence by using the radial velocity method, carefully measuring tiny wobbles in the movement of Proxima Centauri caused by the planet's gravitational pull. This discovery was a historic breakthrough, proof that potentially habitable planets exist right next door in cosmic terms. But Proxima Centauri B wasn't the only surprise waiting to be found. Music, mysterious signal from Proxima Centauri. In April and May of 2019, astronomers at Parkes Observatory in Australia detected strange radio signals coming from the direction of Proxima Centauri. These signals, recorded over a span of 30 hours, were observed at a specific frequency of 982.2 megahertz. Could this be a message from an alien civilization? Analyzing the signal to determine the origin of this anomaly, scientists carefully analyzed its frequency shift. The results were astonishing. The shift in frequency closely matched the orbital movement of Proxima Centauri B, suggesting the signal could be linked to the planet. However, the signal mysteriously vanished shortly after detection. In 2020, a second attempt to re-establish a connection was unsuccessful. By 2021, researchers calculated that the probability of an intelligent species residing in Proxima Centauri and producing radio communication was 1 in 10 to the power of 8, an extremely low chance. So, if this signal wasn't from extraterrestrial life, what was its true origin? The violent nature of Proxima Centauri. Since 2017, astronomers have used the Atacama Large Millimeter Array to monitor activity around Proxima Centauri. Their findings were alarming. Proxima Centauri is a highly active red dwarf, prone to massive solar flares. One of these coronal ejections increased in brightness 1,000-fold in just 10 seconds, lasting for nearly 2 minutes. This is bad news for Proxima Centauri b. The planet is constantly bombarded with intense radiation, making it almost impossible for an atmosphere to survive. Without an atmosphere, liquid water cannot exist, meaning life as we know it would struggle to survive. Another major issue is Proxima b's orbit. The planet completes one full orbit in just 5.12 Earth days, meaning it is extremely close to its parent star. Even though red dwarfs are cooler than our Sun, such proximity would still expose the planet to extreme temperatures. This leads scientists to believe that Proxima Centauri b is likely uninhabitable. A new hope, the discovery of Proxima d. But Proxima Centauri still had surprises in store. Between 2020 and 2022, researchers using the espresso spectrograph on the Very Large Telescope, VLT, detected a mysterious object transiting Proxima Centauri. After months of study, they confirmed the discovery of a new exoplanet, Proxima d. Key facts about Proxima d: estimated radius 0.8 times that of Earth mass, twice that of Mars. Discovery method: radial velocity measurements. Although scientists haven't determined whether Proxima d could support life, its discovery is still groundbreaking. Why? Because it shows that our closest neighboring star system is filled with intriguing new worlds, hinting that planets may be far more common than we once believed. What this means for the future: even if Proxima Centauri b and d are not habitable, the bigger picture is what matters. The Alpha Centauri system is packed with planets, making it a prime target for future exploration. The discovery of more exoplanets increases the chances that somewhere out there, life may exist. Understanding these planets helps us prepare for interstellar travel, a goal humanity may one day achieve. Expanding the scope of discovery: even if Proxima Centauri b and Proxima d are not habitable, their discovery suggests something far more exciting. There are countless other exoplanets beyond what we can currently detect. But what do we mean by the current scope of discovery? How do we detect exoplanets? Scientists primarily use two main methods to detect planets outside our solar system. 1. The transit method. This is the most commonly used technique. Telescopes observe stars for long periods, looking for small but regular drops in brightness. When a planet moves between us and the star, it blocks some of the star's light, creating a detectable dip in brightness. The size and frequency of these dips help astronomers determine the planet's size and orbit. 2. The radial velocity method, Doppler spectroscopy, also called the wobble method. This technique relies on the fact that a planet doesn't just orbit a star. Both the planet and the star orbit a shared center of mass, called the barycenter. This gravitational tug makes the star slightly wobble, which affects the wavelength of its light. As the star moves toward us, the light waves shorten, blue shift. As it moves away from us, the light waves stretch, red shift. By tracking these Doppler shifts, astronomers can confirm the presence of a planet and even estimate its mass and orbit. Limitations of current methods. These techniques are highly effective for detecting large exoplanets, but they struggle with smaller, Earth-like worlds. Larger planets block more starlight or create a stronger gravitational wobble, making them easier to detect. Smaller planets, like Proxima Centauri b, have less impact on their parent stars, making them harder to find. The numbers speak for themselves. Out of 32,737 confirmed exoplanets in the NASA Exoplanet Archive, only 36 have a smaller mass than Earth. Right now, we mostly detect gas giants, which are less likely to be habitable than smaller, rocky mini-Earths. The future of exoplanet discovery. So, how do we change this? The answer lies in cutting-edge space telescopes, like the James Webb Space Telescope, JWST. The launch of JWST was a historic moment for astronomy, marking the next era of exoplanet exploration. With its unprecedented sensitivity and infrared capabilities, JWST will detect and study the light from the first galaxies ever formed, search for habitable exoplanets with greater precision than ever before, capture images so detailed that we may even confirm whether Proxima Centauri b has an atmosphere. This is more than just scientific progress. It's a revolution in how we understand our place in the universe. The search for another Earth has only just begun. If a planet has an atmosphere, its winds will redistribute heat to its cooler side. This makes it possible to measure how much heat the planet radiates in the infrared spectrum. As the planet orbits its star, we primarily observe its cooler side, depending on its position. If an atmosphere is present, the heat will be evenly distributed, resulting in minimal temperature fluctuations. However, without an atmosphere, the heat emitted towards us will fluctuate significantly as the planet moves. For the first time in history, astronomers have the opportunity to directly observe planets beyond our solar system. This breakthrough opens up a vast array of possibilities. Not only can we detect the presence of an atmosphere, but we can also determine its exact composition. For example, the presence of ozone would absorb specific frequencies of infrared light, creating distinct gaps in the spectrum. The James Webb Space Telescope, JWST, can record these variations. Imagine a hypothetical alien civilization observing Earth. By identifying ozone lines in our planet's spectrum, they could conclude that Earth has an ozone layer and consequently oxygen, which supports life. Similarly, we can apply the same technique to study exoplanets. Moreover, JWST can determine a planet's axial tilt and its size relative to its star. These factors are crucial for understanding planetary conditions and their potential to support life. As JWST continues its mission from its position at Lagrange point L2, it is undergoing calibration and preparation for its initial observations. Soon, it will begin unraveling the deepest secrets of our universe. When we discuss JWST, we are referring to the immediate future of exoplanet studies. But what lies ahead in a more distant yet foreseeable future? The possibility of interstellar travel. Currently, space travel remains within the realm of science fiction, with concepts like hyperspace engines and warp drives. However, Breakthrough Starshot is a pioneering initiative that aims to send spacecraft to the Alpha Centauri system within 20 to 30 years. These spacecraft, equipped with light sails, could achieve speeds of 15 to 20% of the speed of light by utilizing ultra-powerful lasers. This ambitious project has garnered the attention of space enthusiasts, including Facebook's founder, Mark Zuckerberg. The project consists of multiple phases. The first phase involves deploying a base station in orbit, from which small probes will be launched. The second and most challenging phase requires the construction of an extensive network of high-powered lasers worldwide. Due to Earth's rotation, each probe, measuring approximately 4 by 4 meters, will be accelerated by multiple lasers, each generating power equivalent to 1 terawatt hour. To put this into perspective, the total energy consumption of cryptocurrency mining worldwide is about 121 terawatt hours per year. Breakthrough Starshot's founders, including Yuri Milner and the late Stephen Hawking, plan to send 1,000 such probes to Alpha Centauri. Despite the enormous scale of the project, its estimated cost is between $5 and $10 billion, comparable to the budget for JWST. Given the immense scientific value of these projects, their potential impact on our understanding of the universe is immeasurable. The future of space exploration is closer than we think. With advanced telescopes like JWST and visionary projects like Breakthrough Starshot, humanity is on the brink of making unprecedented discoveries about distant worlds and perhaps even the potential for extraterrestrial life. A new era of space exploration. Imagine if we could send probes to the stars. This could be the penultimate step in preparing for the colonization of faraway worlds. Such missions would allow humanity to gather critical information about the planets we might one day visit. More importantly, it could help answer the ultimate question: how many habitable worlds are out there? And how likely is the existence of life beyond Earth? Not just life as we know it, but also the more exotic possibilities, the kinds of life that science fiction has imagined for decades. Could we find alien life? One of the most fascinating prospects of exoplanet exploration is the possibility of non-standard life forms, organisms that exist in environments vastly different from Earth. Take Proxima Centauri b, for example. This exoplanet orbits Proxima Centauri, a star that is known for its violent solar flares. Every 10 to 30 hours, it bombards the planet with intense radiation, far more than what we experience on Earth. Under such conditions, life as we know it would struggle to survive. But could alien life exist beneath the planet's surface, or deep within its oceans, shielded from the deadly radiation? The science of survival. Even on Earth, we have discovered organisms that can endure extreme environments: bacteria thriving in nuclear reactors, deep-sea creatures living near hydrothermal vents, and microorganisms surviving in the vacuum of space. On Proxima Centauri b, alien organisms might have evolved unique survival mechanisms. Scientists speculate that some life forms could absorb ultraviolet radiation and convert it into biofluorescent light, essentially glowing in the dark. If such life exists, imagine what we could find just a few feet beneath the surface of Proxima b. Perhaps even an entire civilization of biofluorescent creatures, lighting up their world in eerie, otherworldly colors. The future of space discovery, with the James Webb Space Telescope and ambitious projects like Breakthrough Starshot, we are on the verge of unraveling the mysteries of the cosmos. The more we explore, the closer we get to answering, are we alone? Or are we just one of countless civilizations scattered across the galaxy, a glowing mystery on Proxima b? Take Earth as an example. As we explore the depths of our own oceans, we discover incredible adaptations. Certain coral polyps contain fluorescent proteins that are activated by UV radiation at wavelengths between 315 to 400 nanometers in the long wave range and 420 to 700 nanometers in the blue spectrum. These proteins convert harmful radiation into a longer wavelength of light, creating a mesmerizing glow. Now, imagine if life on Proxima b had developed a similar adaptation. If organisms on this distant world evolved the ability to convert radiation into visible light, then the planet itself could glow brightly at certain wavelengths, possibly even within the visible spectrum. With advanced technology like the James Webb Space Telescope, such an incredible phenomenon might actually be detectable. Expanding the horizons of humanity, the study of exoplanets is more than just scientific curiosity. It brings us closer than ever to answering one of humanity's greatest questions. Are we alone in the universe? But beyond that, this research opens the door to an even bigger possibility: the expansion of humanity across the stars. If planets like Proxima b can support life, even in extreme conditions, then who's to say that one day we won't find a world that we too could call home? The unimaginable vastness of space. When we truly contemplate the scale of the universe, it's impossible not to feel a mix of awe and terror. The endless void stretching in all directions, the unstoppable power of black holes, capable of erasing matter from existence, the billions of distant exoplanets, so mysterious and unreachable that they feel almost unreal. And yet, our curiosity persists. Worlds unlike any other. Today, we'll explore 6 incredible exoplanets, each more extreme than the last. Some are blazing infernos, others are frozen wastelands, and a few defy even the wildest imagination. The first on our list, Korot 7b, a world where the rain isn't water, but molten rock. Stay tuned as we journey through the most terrifying and fascinating planets ever discovered. Korot 7b, the planet where it rains rocks. Imagine a world where the sky doesn't pour water, but molten rock. Welcome to Korot 7b, an exoplanet just 1.5 times the size of Earth, yet utterly uninhabitable. At around 1.5 billion years old, this planet orbits 489 light-years away in the Monoceros unicorn constellation. When it was discovered in 2009, scientists were excited. It was the first rocky exoplanet resembling Earth, but any hope of habitability quickly vanished. A sunrise, that means instant death. If you were somehow standing on Korot 7b, watching the sunrise would be your last moment. Its host star, Korot 7, blazes 60 times closer to the planet than our sun is to Earth. That means the star appears 360 times larger in the sky. As soon as its rays touch the surface, temperatures soar to a staggering 4,700 degrees Fahrenheit, 2,600 degrees Celsius. Hot enough to melt and vaporize rock instantly. A storm like no other. But the most incredible phenomenon on this planet is its weather. As the molten rock on the surface evaporates, the vapor rises into the atmosphere. There, it condenses into tiny rock particles, like water turning into rain on Earth. But instead of gentle droplets, Korot 7b experiences a downpour of burning hot gravel, falling back to the surface like a never-ending volcanic storm. A world split in two. Adding to its hellish nature, Korot 7b is tidally locked, meaning the same side always faces the star. The day side is a lava ocean, constantly scorched by the star's heat. The night side is an icy wasteland, where temperatures plummet to negative 390 degrees Fahrenheit, or negative 234 degrees Celsius. There is no escape. One side burns, the other freezes. A glimpse into the extreme, Korot 7b, is a chilling reminder that not all Earth-like planets are welcoming. Some worlds, like this one, are locked in a never-ending battle between fire and ice, where even the weather is made of molten rock. And this is just the beginning. Next, we explore another exoplanet with even more extreme conditions, one that defies the very laws of nature. Stay tuned, J. J1407b, the planet with colossal rings. If you thought Saturn's rings were impressive, wait until you hear about J1407b, a gas giant with rings so massive they defy imagination. A ring system 200 times larger than Saturn's J1407b's. Rings stretch across a mind-blowing 110 million miles. That's 20% more than the distance from Earth to the Sun. For comparison, Saturn has three main rings. J1407b has 30 rings, spanning a cosmic highway of rock and ice. To put that into perspective, Saturn's largest ring spans 300,000 miles, but J1407b's rings are 366 times wider. A planet born from cosmic destruction. How did such colossal rings form? Astronomers believe there are two possible explanations. A moon-shattering catastrophe, J1407b, 10 to 40 times the mass of Jupiter, has an insanely strong gravitational pull. This powerful force may have ripped its own moons apart, scattering countless chunks of ice and rock into orbit. A young world in the making. Some scientists suggest J1407b is still in the process of forming. The massive ring system could be a nursery for new moons, just like how planets formed from the early solar system's dust and debris. What if J1407b were in our solar system? If this giant existed where Saturn is, its rings would appear so massive in the night sky that they would be visible to the naked eye, more than 100 times bigger than a full moon. A cosmic titan, unlike any other, J1407b is a jaw-dropping example of how bizarre and extreme planets can be. With its planet-sized rings, this gas giant reshapes our understanding of planetary formation. But as strange as it is, J1407b is just the beginning. Up next, we'll explore an even more terrifying world. One that shouldn't even exist. What makes J1407b's ring system unique compared to Saturn's rings? J1407b's rings are unlike anything found in our solar system. While Saturn has the most extensive ring system in our neighborhood, J1407b's rings are a staggering 200 times larger. They stretch over 110 million miles, which is more than the distance from Earth to the Sun, 93 million miles. The rings likely formed due to the destruction of one or more moons, possibly from a massive collision. The presence of gaps in the rings suggests that either new moons are forming within them, or that a significant celestial event has shaped their structure. Another unique aspect is that J1407b itself might not be a typical gas giant, but a failed star protostar. It's debated whether this object should be classified as a brown dwarf or a planet, since it has characteristics of both. Unlike binary stars, which orbit around a mutual center of gravity, J1407b orbits its host star like a regular planet, adding to the mystery of its identity. 2. Could life exist on Proxima Centauri b despite its extreme conditions? Proxima Centauri b, the closest exoplanet to Earth, orbits Proxima Centauri, a red dwarf star known for its violent stellar flares. Every 10 to 30 hours, this star sends out bursts of intense radiation, which could make the planet's surface highly inhospitable. However, life could still exist under certain conditions. Subsurface life. Microorganisms could thrive beneath the planet's surface, shielded from the deadly radiation. Deep sea life. If Proxima Centauri b has liquid water, life might exist deep in its oceans, much like deep sea creatures on Earth. that survive without sunlight. Biofluorescent organisms. Some theoretical models suggest that alien life could have evolved UV-absorbing proteins that allow them to convert harmful radiation into harmless or even useful energy, similar to how some corals on Earth react to UV light. While these possibilities remain speculative, future space telescopes like James Webb could detect biosignatures, chemical markers that hint at life, through the study of exoplanet atmospheres. 3. How does Coro 7b's rock rain phenomenon occur? Coro 7b is a planet where it literally rains rocks due to extreme heat. The process works as follows. Extreme temperatures. Corot 7b orbits its star 60 times closer than Earth orbits the Sun. This means the star appears 360 times larger in the sky, and temperatures can reach 4,700 degrees Fahrenheit or 2,600 degrees Celsius. Rock vaporization. At such high temperatures, rocky materials on the planet's surface vaporize, turning into a superheated gas. Condensation in the upper atmosphere. This rock vapor rises into the upper layers of the atmosphere, where temperatures are slightly cooler. There, it condenses into tiny solid particles, just like water vapor condenses into raindrops on Earth. Rock rain. Once enough condensation occurs, these solid particles become heavy enough to fall back to the planet's surface, creating a storm of falling rock fragments instead of water droplets. To make matters worse, Coro 7b is tidally locked, meaning one side always faces the star and is constantly exposed to extreme heat, while the other side remains permanently dark and freezing cold. The planet likely started as a gas giant, but over time, its atmosphere was stripped away, leaving only a rocky core behind. This makes Coro 7b an extremely inhospitable place, one of the most hellish exoplanets discovered so far. 4. What challenges would humanity face in exploring exoplanets like Proxima Centauri b? Traveling to and exploring exoplanets is one of the biggest challenges in space exploration. The biggest obstacles include vast distances. Proxima Centauri b is 4.24 light years away. With current technology, even the fastest spacecraft, Voyager 1, would take over 73,000 years to get there. Newer propulsion methods, such as light sails powered by laser beams, could theoretically reduce the travel time to 20 to 30 years. Survivability and radiation. Even if we reach an exoplanet, astronauts would face intense radiation, especially from active red dwarfs like Proxima Centauri. Shielding technologies and underground habitats would be necessary for survival. Communication delay. Even at light speed, a message to Proxima Centauri b would take 4.24 years to reach Earth. A two-way conversation would take over 8 years, making real-time communication impossible. Finding suitable landing spots. Without detailed maps, we wouldn't know where to land safely. Future probes must be highly autonomous, capable of making decisions without human input. Despite these challenges, projects like Breakthrough Starshot are working on developing nano spacecraft that could reach Proxima Centauri b within a few decades, sending back critical data about its environment. 5. Why is the discovery of exoplanets important for humanity's future? The discovery of exoplanets is one of the most exciting developments in modern astronomy because it helps us answer some of the biggest questions about the universe and our place in it. Are we alone? Studying exoplanets allows us to look for biosignatures, gases, and chemical compositions that indicate the presence of life. If we find even microbial life on another world, it would revolutionize our understanding of biology and evolution. Finding a second Earth. Earth won't be habitable forever. Climate change, resource depletion, and long-term cosmic events, like asteroid impacts or the sun's eventual expansion, mean that humanity needs a backup plan. Searching for Earth-like exoplanets could one day lead us to a new home, expanding human knowledge. Every exoplanet discovery pushes our understanding of planet formation, atmospheric conditions, and the limits of habitability. Some exoplanets have diamond cores, others have rock rain, and some orbit dead stars, challenging what we thought was possible. Advancing space travel. The more we learn about distant planets, the better we can develop technologies to reach them. Future advancements in warp drives, cryogenic sleep, and artificial gravity could make deep space travel a reality. In short, the discovery of exoplanets is more than just scientific curiosity. It's a crucial step toward humanity's survival and expansion into the universe, the drifters of the universe. Rogue planets. Not all planets have a star to call home. Some wander alone, drifting endlessly through the cold emptiness of space. These are rogue planets, also known as orphan or nomad planets. Worlds that were once part of a solar system, but were violently ejected by powerful gravitational forces. One of the most intriguing rogue planets is PSOJ 318.5-22, a gas giant 8 times the size of Jupiter. Unlike typical exoplanets, PSOJ 318 doesn't have a host, star-blinding astronomers with excess light, making it much easier to observe using infrared telescopes like Pan-STARRS, Panoramic Survey Telescope, and Rapid Response System. A dark world with fiery storms. Despite being a rogue planet, PSOJ 318 glows brightly in infrared due to its intense internal heat. Scientists have taken hundreds of infrared images and uncovered some fascinating facts. Cloud layers. The planet has thick and thin clouds moving at incredible speeds. Extreme temperatures. The surface temperature reaches 1,470 degrees Fahrenheit, 800 degrees Celsius. Hot enough to melt lead. Fast rotation. PSOJ 318 completes a full rotation every 5 hours, much faster than Jupiter. Iron rain and supersonic dust storms, using the Very Large Telescope, VLT, in Chile. Astronomers predicted storm winds faster than the speed of sound, carrying clouds of molten iron droplets, a true cosmic hurricane. The fate of rogue planets. How do planets like PSOJ 318 end up alone in the void? Scientists propose 3 main theories. Failed stars. Some rogue planets started as protostars, but failed to gather enough mass to ignite into a full-fledged star. Supermassive gas giants. Others may have formed as gas giants multiple times larger than Jupiter, but never got close enough to a star to evolve further. Exiled planets. Some were part of young planetary systems, but were gravitationally ejected after close encounters with another massive planet or star. Once cast out, they never return, doomed to drift forever, unless they are captured by another star system. Many scientists debate how to classify such objects. Some believe PSOJ 318 is not just a planet, but a sub-brown dwarf, a celestial body that sits somewhere between a planet and a failed star. Although only a handful of rogue planets have been discovered, this is just the beginning. Advanced telescopes, like the James Webb Space Telescope, are expected to reveal thousands of these mysterious travelers, shedding light on their hidden secrets. The doomed world of WASP-12b. If rogue planets drift alone in eternal exile, Some planets suffer an even worse fate: slow destruction at the hands of their own star. Meet WASP 12b, one of the most doomed planets in the universe. This gas giant, twice the size of Jupiter, is caught in a deadly gravitational dance with its host star, spiraling toward oblivion. A planet being torn apart. Unlike Jupiter, which takes 12 years to orbit the Sun, WASP 12b completes a full orbit in just 24 hours. This means it's incredibly close to its star. So close that tidal forces are ripping the planet apart. Due to these intense forces, egg-shaped distortion. Instead of being a perfect sphere, WASP 12b is stretched into an egg-like shape due to the gravitational pull of its star. Superheated atmosphere. The surface temperature exceeds 4,000 degrees Fahrenheit, 2,200 degrees Celsius, hot enough to vaporize metal, losing mass into space. The star is literally sucking material from the planet's atmosphere, slowly consuming it piece by piece. The countdown to destruction. Astronomers estimate that WASP 12b won't survive much longer. In about 10 million years, it will be completely shredded apart, leaving nothing but a ring of debris around its dying star. This marks one of the few times scientists have actually witnessed a planet being destroyed in real time, offering a rare glimpse into the violent life cycle of planets. The universe is full of surprises, from rogue planets wandering alone to gas giants being devoured by their stars. The universe is filled with extreme, unimaginable worlds, and with each new discovery, we get closer to understanding the incredible diversity of planets beyond our solar system. Who knows? The next big discovery could change everything we thought we knew about the cosmos. The final days of WASP 12b, a planet being consumed. The destruction of WASP 12b is more than just a spectacle. It's a glimpse into a rare cosmic event. The planet, already distorted by the immense tidal forces of its star, will fall apart completely in just a few million years. As it disintegrates, it will form a cloud of gas and dust, which will eventually be absorbed by the star itself. This gravitational death spiral accelerates as WASP 12b exchanges matter with its star, something previously thought to happen only between stars in binary systems. But here we are, witnessing it happening to a planet for the first time, a world of fire, water, and diamonds, with temperatures soaring to 4,100 degrees Fahrenheit, 2,260 degrees Celsius. WASP 12b is a true inferno, making life utterly impossible. Yet, in 2015, something unexpected happened. Astronomers using the Hubble Space Telescope detected traces of water vapor in the atmosphere. A shocking discovery, considering the extreme environment. And the surprises don't end there. This planet could have a surface made of graphite and diamonds due to its unusually high carbon content. This led some media outlets to nickname it the Diamond Planet. However, most of this carbon likely exists in the form of carbon monoxide and methane gas rather than solid gemstones. Adding another layer of mystery, a possible moon, WASP 12b1, was detected in 2012. With a radius 6.4 times that of Earth, it is almost one-third the size of WASP 12b itself. But what conditions exist on this moon? Given its proximity to a dying world, we can only imagine a hostile, chaotic landscape, not much better than its doomed neighbor. The mystery of Fomalhaut b, a planet that never existed from one dying planet to another. Bizarre cosmic mystery. Let's travel 25 light years away to the bright star Fomalhaut, one of the most visible stars in our night sky. In 2004, the Hubble Space Telescope detected a massive ring of cold debris around Fomalhaut, hinting at the possible existence of a hidden exoplanet. Excitement grew as astronomers predicted this planet, nicknamed Dagon, to be 3 times the size of Jupiter. For years, nobody could actually see it. But in 2008, a breakthrough moment arrived. An image of the mysterious object was finally captured, sending shockwaves through the scientific community. But then, things started to go very, very wrong. The planet that vanished. Instead of behaving like a planet, Dagon acted strangely. Its speed kept increasing. Unlike any known planetary motion, its brightness changed unpredictably, becoming dimmer while appearing larger in size. It had no gravitational effect on the debris ring around Fomalhaut, something expected of a large planet. Then, in 2014, Dagon did something completely unprecedented. It vanished. After years of observation, it simply disappeared from the sky. No planet should be able to do that. Exoplanets don't just evaporate. The shocking truth: Dagon never existed. Scientists were forced to reconsider everything they thought they knew about this so-called planet. After reanalyzing all the data, astronomers proposed a new, radical explanation. Dagon was never a planet at all. Instead, it was likely a massive dust cloud, the aftermath of a catastrophic planetary collision. In other words, what we thought was an exoplanet was actually the remnants of 2 planetary bodies colliding at incredible speeds, throwing up a vast cloud of debris that temporarily reflected starlight before dispersing into nothingness. This makes Fomalhaut B one of the most puzzling cases in exoplanet research, a discovery that turned out to be an illusion created by cosmic destruction. The universe is full of surprises, from planets being devoured to planets that never existed. The universe continues to challenge our understanding. Every new discovery brings with it more questions, mysteries, and unexpected revelations. With next-generation telescopes, like the James Webb Space Telescope, we are only beginning to unravel the true nature of these distant worlds. Who knows? Maybe the next great cosmic mystery is just waiting to be uncovered. The cosmic illusion, the truth about Fomalhaut B. What if an entire planet turned out to be nothing more than a mirage? For years, astronomers believed they had discovered an exoplanet orbiting the bright star Fomalhaut, one of the most visible stars in the night sky. They called it Dagon. But in 2014, the shocking truth was revealed. Dagon was never a planet at all. Instead, new evidence suggests it was a slowly dissipating cloud of dust formed by a massive collision between 2 planetary bodies, possibly asteroids or planetesimals. A string of cosmic coincidences. This discovery is even more astonishing when you consider how rare such planetary collisions are. The event must have occurred sometime around 2004, just when the Hubble Space Telescope happened to be surveying the region. Coincidence number 1. Over time, the dust cloud expanded, creating the illusion that Dagon was growing in size while getting dimmer. Coincidence number 2. The bizarre eccentric orbit wasn't planetary at all, but simply the natural dispersal of debris. Coincidence number 3. Instead of following the expected elliptical path of a planet, the cloud moved along a runaway trajectory, drifting farther into space. A series of cosmic coincidences misled astronomers into believing in a phantom world, a planet that never truly existed. Although Fomalhaut B lost its exoplanet status, the discovery reminds us that the universe is still full of countless confirmed exoplanets, each waiting to reveal its own secrets. Now, let's leave behind this illusionary planet and set our sights on something even more extraordinary, a world that has existed since the dawn of time. Captain B, a window into the ancient universe. What if there was a planet twice as old as Earth? A place that may have witnessed the very origins of the universe itself. Meet Captain B, a planet located just 13 light years away, yet older than almost any known exoplanet. Scientists estimate its age to be 11.5 billion years, making it 2.5 times older than Earth. Only 2 billion years younger than the universe itself. This planet has existed since the earliest days of the Milky Way, orbiting its host star, Captain Star, a red subdwarf with a mass only a quarter of the Sun's. Could life have existed for billions of years? Captain B is intriguing not just because of its age, but because it sits in the habitable zone of its star, where conditions might allow liquid water to exist. Although the star emits 250 times less light than the Sun, Captain B orbits at a distance of 0.168 astronomical units, even closer than Mercury is to our Sun. Scientists estimate its surface temperatures to be minus 58 degrees Fahrenheit, minus 50 degrees Celsius on the dark side, 50 degrees Fahrenheit, 10 degrees Celsius on the sunlit side. With these conditions, could life have survived here for billions of years? A strong candidate for extraterrestrial life. Captain B has an Earth Similarity Index, ESI, of 0.67, comparable to other promising exoplanets like Kepler 62f and KOI 457.01. Life takes billions of years to evolve. If 4.5 billion years were enough for intelligent beings to appear on Earth, just imagine what 11.5 billion years might have allowed on Captain B. Perhaps ancient life forms once thrived here, watching the galaxy evolve over time. Perhaps, even now, something is still there, observing us from the darkness of space. But our journey doesn't end here. Now, let's step into the most mysterious and powerful force in the universe, the realm of black holes. Black holes, destroyers or creators. For decades, black holes have been feared as monsters of the cosmos, ravenous voids that consume everything, even light itself. But what if they are more than just cosmic destroyers? What if they are also creators, shaping entire galaxies and giving birth to new star systems? Let's take a closer look at the true nature of black holes, the most powerful and enigmatic objects in the universe. Black holes, the cosmic paradox. What are black holes, really? For decades, black holes have fascinated and terrified us. But before we go deeper, let's address a fundamental question. Are black holes really holes? And are they actually black? Ask a physicist, an astronomer, or a mathematician, and their answers may be similar, but their approach will differ. Why? Because within a black hole, the laws of physics as we know them cease to function. According to Einstein's theory of general relativity, gravity within a black hole warps space-time so much that it essentially tears a hole in reality. So how do these cosmic monsters form? And could any star collapse into one? The birth of a black hole. The formation of black holes is still a subject of scientific debate. However, the leading theory, gravitational collapse, suggests that a black hole can only form when a dying star has a mass between 2.5 to 5.6 times that of our Sun. Yet, once formed, the black hole itself is shockingly small. If our Sun were to collapse into a black hole, It would shrink from its current 432,000-mile radius to just 1.9 miles, barely the size of a small city. For Earth, that figure is even more mind-boggling. It would need to be compressed to the size of a grain of rice to become a black hole. This extreme compression is determined by a limit known as the Schwarzschild radius, named after astronomer Carl Schwarzschild, who first discovered the mathematical pattern behind this phenomenon. And here's the crazy part. Any object in the universe, if compressed beyond its Schwarzschild radius, could theoretically become a black hole. Yes, even you, if you could somehow shrink to a fraction of a nanometer. The event horizon, a point of no return. There are two major ways to interpret black holes. One consistent with general relativity, one consistent with quantum mechanics. According to general relativity, a black hole is defined by its event horizon, a spherical boundary beyond which nothing, not even light, can escape. Crossing this boundary is like stepping off the edge of reality itself. Outside the event horizon, you can still escape, if you're fast enough. Inside the event horizon, no force in the universe can save you at the speed of light. Not even traveling. From the outside, a black hole might appear as an invisible void, but in reality, it has no solid surface. It's simply a region of space-time, so warped by gravity that it traps everything within it. Inside a black hole, a journey into the unknown. What would happen if you fell into a black hole? As you approach the center, space-time would become more and more distorted, until, at the very core, you'd reach the gravitational singularity. At this point, space and time cease to have any meaning. All known laws of physics break down. Reality itself dissolves. Imagine walking through a dark room. You feel around for walls and doors. If you stumble upon a door, you know you've passed into another space. But falling into a black hole is different. There's no door, no transition, no indication that you've crossed an invisible threshold. To the outside world, you'd simply appear to freeze in time. At the event horizon, your image would stretch and distort as light from you gets redshifted into oblivion. But from your perspective, you'd continue falling, deeper, faster, into a place beyond the reach of the universe itself. And then, nothing. The ultimate mystery. Black holes are more than just devourers of light. They are paradoxes, where physics breaks down, where space and time twist into something we can't yet understand. Scientists still debate what lies beyond the event horizon. Does matter truly vanish forever? Is there a hidden portal to another universe? Or could black holes, paradoxically, be the cradles of new stars and galaxies? One thing is certain. Black holes are among the most mysterious and powerful objects in the cosmos. And as we continue to explore the universe, they will challenge our understanding of reality itself. Would you dare to take the plunge? Falling into the abyss. A tale of two realities. If you were to fall into a black hole, something bizarre would happen. To you, the journey would seem calm, surreal, almost dreamlike. You'd drift deeper into the abyss, free falling without resistance. No turbulence, no pressure, just an endless descent through twisted space-time. But to an outside observer, you would appear frozen at the event horizon, trapped in time itself. Eventually, your image would fade away, stretched beyond recognition, until you disappeared from the universe entirely. Which reality is correct? According to physics, both. Spaghettification, the ultimate stretch. This eerie freefall only applies to supermassive black holes, millions of times larger than our sun. If you were unlucky enough to fall into a smaller black hole. The experience would be far less peaceful. As you approached, the gravitational pull on your feet would be significantly stronger than the pull on your head, stretching your body into an infinitely thin strand, a process scientists call spaghettification. Yes, that's the actual scientific term. For this thought experiment, let's assume we're inside a massive black hole where our descent is slow, allowing us to explore one of the greatest mysteries of the cosmos, the paradox of information, the paradox of existence. Do you truly vanish? According to Stephen Hawking, once you enter a black hole, your atoms cease to exist. From an observer's perspective, you never cross the event horizon. You remain suspended, fading away into nothingness. But that creates a problem. One of the fundamental laws of quantum physics states that information can never be destroyed. Every particle in the universe holds unique data about its existence. If a black hole erases that data permanently, it violates one of the core principles of physics. This is known as the black hole information paradox, a problem that baffled physicists for decades. Hawking radiation, the slow death of a black hole. Hawking discovered something extraordinary. Black holes aren't eternal. At the event horizon, quantum effects generate tiny virtual particles. Normally, these particles annihilate each other instantly, but in rare cases, one particle falls into the black hole, while the other escapes into space. This escaping particle becomes Hawking radiation, slowly bleeding energy from the black hole. Over 10 to the power of 100 years, a supermassive black hole will completely evaporate, leaving behind nothing. But if a black hole evaporates, what happens to everything that fell inside it? Is all that information truly lost? The fuzzball theory, a new reality. In an attempt to solve this paradox, physicists proposed a groundbreaking idea. Black holes might not be holes at all. Instead, they could be gigantic tangled structures of quantum energy, something scientists now call fuzzballs. This theory, rooted in string theory, suggests that a black hole is not an empty void, but rather a chaotic mass of vibrating quantum strings. Here's what this means. There is no singularity. There is no instead of falling in of a black hole. Objects merge with the fuzzball, altering its quantum state. This solves the information paradox. Instead of being erased, your quantum information gets encoded into the vibrations of the fuzzball itself, a universe without a center. If fuzzball theory is correct, then black holes aren't objects in the traditional sense. There is no smooth event horizon, no perfect sphere of darkness, just a storm of quantum chaos, distorting everything around it. And this has even bigger implications. Could fuzzballs explain the Big Bang? Could they be gateways to new universes? Do they hold the key to unifying general relativity and quantum mechanics? As we continue to explore the universe, black holes remain one of the greatest mysteries of all time. And perhaps, one day, we'll finally unlock the truth hidden within the darkness. Entropy, information, and the wormhole solution. There's one more puzzle piece left to solve. If black holes evaporate through Hawking radiation, they emit photons. But there's a problem. The entropy of these photons is too high to match the principles of quantum mechanics. Entropy and the fate of information. Entropy is a measure of disorder, the way energy spreads throughout the universe. The rules of quantum mechanics demand that the entropy of emitted photons should be less than the black hole's entropy. But in Hawking's model, the numbers don't add up. To fix this contradiction, scientists introduced an extraordinary idea. something known as the wormhole paradigm, a bridge through space-time. Instead of treating black holes as isolated objects with a singularity at the center, what if they were connected to the universe through tiny quantum bridges, wormholes, by factoring in both the photons escaping from a black hole, the particles falling into it? Physicists realized that the entropy puzzle vanishes, and if black holes are really fuzzballs, as string theory suggests, then this problem is solved entirely. No singularity, no paradox, no lost information. A new cosmic discovery, black holes that give birth to stars. Then, in January 2022, something incredible happened. Hubble, the legendary space telescope, made an unexpected discovery that could revolutionize our understanding of black holes. While observing the distant galaxy Hennes 2-10, located 30 million light-years away, Hubble detected radiation flowing outward from the galaxy's core. This was strange. Normally, black holes consume everything around them, not create. A black hole that sparks life. Spectroscopy revealed that this radiation was moving at 1 million miles per hour, crashing into a dense gas cloud. But instead of tearing it apart, the radiation compressed the gas, triggering the formation of newborn stars. Why does this matter? In larger galaxies, powerful black holes emit violent jets of plasma, moving close to the speed of light. These jets heat up any nearby gas clouds, making it impossible for them to cool down and form stars. But in Hennes 2-10, something different was happening. The central black hole was smaller and weaker. Instead of destroying gas clouds, its radiation was just strong enough to compress them, kickstarting the birth of new stars. Could black holes be creators, not just destroyers? For decades, we saw black holes as cosmic monsters, devouring everything, swallowing light, erasing existence. But this discovery suggests something profound. What if black holes don't just end stars? What if they also create them? A universe of endless mysteries, from the paradox of lost information to the fuzzball theory, from wormholes linking spacetime to black holes birthing stars. Every new discovery reshapes what we thought we knew about the universe. And as we continue to explore, one thing becomes clear: black holes are far more mysterious than we ever imagined. Perhaps one day, we'll find the ultimate answer hidden within the heart of darkness. Black holes, destroyers or creators. Whenever we hear the term black hole, we imagine a terrifying cosmic monster that swallows everything in its path. But recent discoveries suggest that black holes don't just destroy, they can also create stars. The Hubble telescope recently observed a small black hole in the galaxy Hennes 2-10, where radiation from the black hole was actually helping form new stars. This is surprising because large black holes usually produce intense heat that prevents star formation. But in this case, the black hole's softer radiation, compressed gas just enough to trigger star birth. This discovery may hold the key to understanding how supermassive black holes formed in the early universe. Multiverse, sci-fi, or reality. Now, if our universe is this strange, could there be more than one? The multiverse theory suggests that our universe is just one of countless others. In quantum mechanics, particles exist in multiple states at the same time. An idea famously illustrated by Schrödinger's cat experiment. A physicist named Max Tegmark took this further, proposing that every possible quantum outcome creates a new universe. If that's true, then an infinite number of universes may exist. There are different levels of the multiverse. Level 1. Universes that exist in the same space-time as ours, but are so far away we can never reach them. Level 2. Universes with different laws of physics. Level 3. A universe is created every time a quantum event happens. Every possible choice results in a new reality. Level 4. Universes with completely different mathematical and physical rules. Beyond anything we can imagine. Does the multiverse really exist? It's still a theory, but each new discovery brings us closer to proving it. Scientists are studying cosmic microwave background radiation and dark matter to find clues. If the multiverse is real, then somewhere out there, another version of you could be living a completely different life. The multiverse, science or science fiction. Imagine looking into a mirror and seeing not just one reflection, but infinite versions of yourself, each living a slightly different life, making different choices, and existing in an entirely separate reality. It sounds like something out of a science fiction novel, doesn't it? But what if I told you that this could actually be real? The idea of the multiverse, a collection of multiple or even infinite universes, has fascinated scientists, philosophers, and storytellers for centuries. But thanks to modern physics, this concept is no longer just an imaginative fantasy. Some of the brightest minds in theoretical physics believe that our universe is not alone. One of the most intriguing and controversial theories on the multiverse comes from physicist Max Tegmark, who proposed that reality itself is nothing but a mathematical structure. According to him, the existence of multiple universes isn't just a possibility, it's a necessity. But before we dive deep into Tegmark's ideas, let's start with the basics. What is the multiverse? At its core, the multiverse theory suggests that our universe is just one of many. But how could that be possible? Well, there are several scientific ideas that hint at the existence of parallel universes. One of the strongest pieces of evidence comes from cosmic inflation. The idea that, after the Big Bang, the universe expanded at an incredible speed. If this inflation happened multiple times in different ways, then it could have created countless universes, each with its own laws of physics and fundamental constants. To better understand this, let's explore Tegmark's 4 levels of the multiverse, each more mind-blowing than the last. Level 1. The observable universe and beyond. The first level of the multiverse isn't as strange as you might think. In fact, it's the easiest to understand. Our universe is huge, but it has a limit. The observable universe. This is the part of space that we can see, limited by how far light has traveled since the Big Bang. But beyond that limit, the universe doesn't just stop. It continues infinitely. If the universe is truly infinite, then statistically speaking, somewhere out there, there must be another Earth, another version of you, and an entire galaxy identical to ours. This isn't science fiction. It's simple mathematics. In an infinite universe, every possible arrangement of particles must eventually repeat, which means there could be countless doppelgangers of you living slightly different lives. But as fascinating as this sounds, it's just the beginning. Level 2. Multiple Big Bangs and bubble universes. Now things get a little more bizarre. If Level 1 describes different regions of our own infinite universe, then Level 2 suggests that there are completely separate universes, each created by their own Big Bang. This idea comes from chaotic inflation, which suggests that space-time itself can stretch and grow forever, creating new bubble universes all the time. Some of these universes may have similar physical laws to ours, while others might be so different that they are unrecognizable. Imagine a world where gravity is 10 times stronger, where atoms never form, or where life exists in ways we can't even imagine. In some universes, the conditions may have been so different that stars never formed at all. If level 1 was strange, level 2 takes us even deeper into the unknown. Level 3, the many worlds interpretation. This is where things get truly mind-bending. Level 3 of the multiverse is based on quantum mechanics, the strange rules that govern the smallest particles in existence. According to the many worlds interpretation, every time a quantum event happens, the universe splits into multiple versions, one for each possible outcome. For example, imagine you're flipping a coin. In one universe, it lands on heads. In another, it lands on tails. But according to quantum mechanics, both possibilities actually happen, and reality branches into two separate worlds. Somewhere out there, there's a version of you who made the opposite choices at every moment of your life. This idea raises mind-blowing questions about free will, destiny, and identity. If every possible version of you exists, then which one is the real you? Level 4, the ultimate multiverse, mathematical reality. Now, we enter the deepest and most controversial part of the multiverse theory. Max Tegmark proposed that at the most fundamental level, reality itself is not physical. It is purely mathematical. Think about it. Everything in our universe, from the smallest atoms to the largest galaxies, follows mathematical laws. The forces of nature, gravity, electromagnetism, the strong and weak nuclear forces, are all described using numbers and equations. Tegmark took this idea to the extreme and asked, what if reality itself is nothing but math? In level 4, universes exist that are governed by completely different mathematical structures. These universes might be so alien that we cannot even describe them with human logic. They may have different types of numbers, dimensions, or even physical laws beyond our understanding. If this is true, then reality is nothing but a giant equation, and everything, including consciousness itself, could just be a mathematical pattern. Is the multiverse real? So, does the multiverse actually exist? Well, despite how mind-blowing and theoretically sound these ideas are, we still have no way to prove them. These universes exist beyond our reach, meaning that, for now, they remain in the realm of speculation. However, new discoveries in cosmic radiation, quantum mechanics, and dark matter may one day give us the evidence we need to confirm or deny these theories. But regardless of whether the multiverse is real or not, the fact that scientists are even considering these ideas tells us one thing. The universe is far stranger, more complex, and more mysterious than we could ever imagine. Final thoughts. If the multiverse is real, then right now, somewhere out there, there is another version of you watching this video. Maybe on a different planet, maybe under a completely different sky. And if Tegmark was right, then reality itself might just be a mathematical illusion, one that we are only beginning to understand. But what do you think? Does the idea of the multiverse excite you, or do you find it too fantastical to be true? Let me know in the comments, and if you enjoyed this deep dive into the mysteries of the universe, don't forget to like, subscribe, and hit the notification bell for more mind-blowing content. Thank you for watching, and I hope you're experiencing this video in the version of the universe where you found all the answers you were looking for. See you next time.